Hi, I'm Brandon Ordonez from ECE31, and today I'm gonna try to perform experiment number 3 for our digital electronics laboratory, which is entitled the exclusive OR and exclusive NOR gates.
Brandon's log.
The objectives of this experiment are to familiarize the students with the basic operations of two-input exclusive OR and exclusive NOR gate, to be able to understand the basic applications of XOR gate. These are the materials needed for our experiment. A 5-volt power supply, a 12-volt power supply, different LEDs, integrated circuits, and a 2N3904 transistor, a 12-volt relay, a 360 ohm resistor, and a 1N4001 diode. Connecting wires and the breadboard, and a 12-volt DC motor. For the first part of the experiment, we would be examining the basic operations of an XOR gate. This experiment would use a 7486 integrated circuit. So let us try to build the circuit. So I have finished building the first circuit for this experiment. So let us try to fill the tables. Upon connecting both inputs to the ground, the LED does not light up. Upon connecting input B to the source, the LED lights up. Upon connecting input A to the source, the LED lights up. And upon connecting both inputs to the source, the LED does not light up. The second part of the experiment is examining the basic operations of an XNOR gate. The circuit uses a 74266 integrated circuit. So let us try to build the circuit. So I have finished building the circuit for the second part of the experiment. Upon connecting both inputs to the ground, the LED lights up. Upon connecting input B to the source, the LED does not light up. Upon connecting input A to the source, with input B to the ground, the LED does not light up. Upon connecting both inputs to the source, the LED lights up. The third part of the experiment is about single direction DC motor control. For the experiment, we will be using an XOR gate, which is a 7486 integrated circuit. So let us try to build the circuit. So I have finished creating the circuit for part 3 of this experiment. Now let us try to complete the table. Upon connecting both inputs to the ground, the motor does not move. Upon connecting input B to the source, the motor moves. Upon connecting input A to the source and input B to the ground, the motor moves. And upon connecting both inputs to the source, the motor does not move. Same as the inputs, both being connected to the ground. For the last part of the experiment, we will construct a half-adder circuit. This circuit would use a 7486 integrated circuit and a 7408 integrated circuit. So let us try to build the circuit. So I have finished building the half-adder circuit, or the last part of our experiment. Note that the blue light represents output S and the red light represents output C. So let us try to fill the tables. Upon connecting both inputs to the ground, the LED does not light up. Upon connecting input B to the source, only the blue light or the S output is lit. Upon connecting input B to the ground and input A to the source, only the S output lights up. Upon connecting both inputs to the source, only the red light or the C output lights up. Now that we are finished with the experiment, let us proceed to the conclusions. As observed in part 1 and part 3, an XOR gate produces an output of 1 when there are different inputs, 1, 0, and 0, 1. On the other hand, an XOR gate produces an output of 0 if the inputs are of the same values, 1, 1, or 0, 0. An XNOR gate can be used directly. If no XNOR ICs are available, one can put a NOT gate after an XOR gate to be able to receive the same output with a regular XNOR gate. As opposed to an XOR gate, an XNOR gate produces an output of 1 if the inputs are of the same values, 1, 1, and 0, 0. The gate would produce an output of 0 if the inputs are of different values. The half-adder circuit was used for 2 inputs and 2 outputs. Both inputs A and B are used for the AND gate and the XOR gate. The outputs are as displayed from the screen. For output S, it is required to have the same values for inputs A and B to obtain a result of 1. On the other hand, for output C, it is required for both inputs to be 1 to obtain a result of 1, since an AND gate use is similar to multiplication, wherein if one of the inputs is 0, the output would be 0. For the recommendations, I recommend that you check your wires first using your DMM to see if they are shorted. Check your power supplies if they are giving approximately equal amount of voltage to the expected power source. And lastly, simulate before proceeding with the experiment to know the expected outcome of the experiment. So that is it for our experiment number 3. I hope you enjoyed watching and bye.